welcome back to the tail end of a Wednesday, or to a Thursday for many of you. I wanted to come on here quickly and say I'm so pleased, first of all, for the Mega Fave Numbers project, that it went so well for all of us. And for me, now that I have a YouTube channel, I'm going to start a series. We're going to have Pwime Numbewednesdays. As one of my friends would say, who is a young child with fantastic intelligence and curiosity. So in that spirit, we're going to explore what makes prime numbers interesting to us. Our first quest is to answer this question. Are there infinitely many Mersenne Prime numbers or not? Humanity has no idea. We do know that there are infinitely many prime numbers, but as for Mersenne Prime numbers, we think there probably are, but we don't know for sure. This is such a compelling question to me personally. The idea that we take something so simple, where we just double and double and double and double and double as many times as we want, and then subtract one, interesting things happen there. Sometimes it's prime, which is called a Mersenne Prime. Sometimes it's not prime, and it has a pattern to it, or does it? The pattern doesn't seem to hold. Oh, maybe there's another pattern. So there's definitely a lot of fascination to explore there, and perhaps we will meet our destination and be able to say a definitive yes or no, but meanwhile the journey is going to be fun. So every Wednesday, except statutory holidays, I'm going to post something about this exploration about Mersenne Prime numbers. Once that is exhausted, maybe we'll go into something else. Maybe twin prime numbers. It's got a W in it. We'll see. Here's a sneak peek for next week. We're going to prove my Klintberg conjecture from my very first video, which was my last video, my previous video. This is now my last video. You know what I mean. A huge thank you to Bjorn P. Munch, who commented on my last video that my Klintberg conjecture is just essentially Fermat's little theorem, which is true. And so because this is true, this is an arrow pointing backwards, it proves that my Klintberg conjecture is true. So we'll go into that next week. Here are some of the pictures we're going to use. Oh my goodness, there's so much detail there. So I'll just go into a taste of one of these. Unexpectedly, we're going to be looking at remainders. So when you take a number and you divide it by something, what remainder can you possibly get? This picture here looks at possible remainders if you divide something by 5. You can have a remainder of 0, of 1, of 2, of 3, or of 4, and then if you have a remainder of 5, you may as well just say you have a remainder of 0, because 5 divides 5. This picture explores what happens to this particular pool of numbers when they are doubled. So for example, 1, if we double it, it doubles to 2. 2, if we double it, it doubles to 4. 3, of course, doubles to 6, which in this world of remainders just wraps around, and 6 is congruent to 1. So 3 becomes 1. And then 4, likewise, becomes 8 that wraps around and is congruent to 3. 0 doubled is just 0, so I have a little arrowhead up here. Now what's interesting about this is that all of these arrowheads are on their own place. So when you double all of these, they all end up as a new identity, but none of them are encroaching on each other's space. So this is possible remainders when you're dividing by 5. Here's some possible remainders when you're dividing by 7. Both of these are prime. Here are some possible remainders when you're dividing by 9, which is not prime but is an odd number. And here are some possible remainders when you're dividing by 12. You'll notice that these do buddy up, and then some of them get missed entirely and don't get an arrowhead at all. So this is part of that proof for next week. tune in next time. Okay, so before I leave, I will also say I'm going to start another series on Mondays about taking cello lessons as an adult student. I'm just now starting cello lessons, so tune into that as well if you like. And then maybe I'll also have another series on Saturdays. Who knows? Right now it'll be Mondays and Wednesdays. So whichever one you choose, I'll see you next time.